Um, back. If you're confused by the last episode or last tutorial rather, it's very understandable because it's something that's kind of very new. Because when we deal with numbers, we're kind of used to, you know, one, two, three, four, five, six, and what does it mean to just have ones and zeros and a combination of that meaning something? So we're gonna get into that. So first thing we're gonna do is we're gonna kind of count from 0 to higher numbers using binary code. So we're just gonna figure out how to do it. Um, so I'm trying to let's try 0. The binary code version of that would actually be 0. Now let's say we're it's 1. Then it's just gonna be 1. So 0 in the decimal world will be 0 in the binary world, 1 in the decimal world will be 1 in the binary world, but it gets more complicated, because then what's a 2? What's 2? How do you represent 2 in binary code? And basically, you represent it like this. 1, 1. So, what is that? 1, 1? That looks like 11. How is 2, 11? Like, what's that about? So, basically, is the system that we're used to is a decimal system. The decimal system. I'm just trying to write this. So if you think about it, how it works is, you know, there's a ones place, right? Um, there's a ones place, there's a tens place, and there could be hundreds place. Can I draw it? Can I draw it? Hundreds place. This is just how a regular decimal number would go, right? And let's say there's even a thousands place. It's gonna be really hard to draw. Thousands place. Sorry about that. So if we were to have the number 3,400, I'm not taking you back to school, but you already know this probably, right? You know, if it was gonna be, you know, in the thousands place 3, in the hundreds place 4, in the tens place 6, in the ones place 1, then we just kind of know that that's 3,461, right? So how does a binary system work? Is basically, I'll kind of type this one out, is something to kind of note um, about how any system works is these all are powers of tens. So 1 is base 10 to the 0. Anything to the 0 is 1, but it's very known that a decimal system is a base 10 system. So how can it be a base 10 system is basically, uh, you know, anything in the ones, like let's say it was 3, right? 3 times 10 to the 0, 10 to the 0, would be still 3. Now, why would you even need that? Because that's indicative of that place. So then 6, let's say we had 6, right? 6, that's going to be times 10 to the 1. That's going to be the tens place. So that's going to be the tens place. 10 to the 1. And 4 times, 100 is going to be 10 to the 2. There's a reason why I'm writing it out this way. There's a reason for it. And then 3 times 10 to the 3. This would be 6. Oh, this would be 60, right? 6 times 10 to the 1. 4 times 10 to the 2, that'd be 400, right? You know that. And then 10 to the 3, 3,000. 1, 2, 3. So, adding all this up, right? If you were to add all these numbers up, you would get to that. So basically, that's a broken down version of the base 10 system. So let's take that, what we know about that, and try to apply it to binary. Is for this situation, right? How binary would work, right? Actually, hold on. I want to actually get this a lot longer. Alright, we're back. So let's, hold on. Oh. Binary system, right? There's gonna be, instead of a 10 to the zeros place, it's gonna be a 2 to the zeros place. Instead of a so instead of a hold on. So instead of okay, so going right here, right? There was a ones place, right? That was a 10 to the zeros place. There's a 2 to the zeros place. So just like a 10 to the ones place, there's a 2 to the ones place. Just like a 2 to the 2, just like a 10 to the twos place, which is the hundreds place, there's a 2 to the twos place. And, then there's a 2 to the threes place. And, we'll get into other things, but basically, let's say you're trying to represent 2. You basically kind of almost see how much it goes into it, for taking the number, breaking down the number 3,461 decimal, right? We would say, that there's a 1 in the ones place, 6 in the sixth place, a 4 in the fours place, and a 3 in the threes place. But here's how you think of breaking down. Here's how you break down converting a number. So basically, you take 2, right? 2 to the third, that's 8. Is an 8 gonna fit into 2? No. 2 to the 2 is 4. Is 4 gonna fit into 2? No. So 2 to the 1 is 2. So that's gonna be a 1. And since you're already done, because we've already used 2, and the number we're trying to convert is 2, the other number would be 0. Oh, it's not a 3. Okay, my bad. My bad. Actually, actually made an error. Hold on, gotta fix it. No, I can't fix it. I can't fix that at all. So 2 would actually be 1, 0. And I'll just cross it out. It'll be 1, 0. Let's say it's the 3. Well, 2 to the 3rd is going to be an 8. 8 doesn't fit in. 2 to the 4 is going to be a 4, so that's not going to fit into 3. But 2 to the 1, 2 fits into 3, right? So now you've already used 2. So now you only have 1 left. And 2 to the 0 is already 1. So 1, 1, a 1 times 2 to the 0 is 1, and a 1 times 2 to the 2, a 1 times 2 to the 1 is 2. That's how you'd represent the number 3. Let's say use a number 4. Sorry, hold on. Let's say you're trying to get the number 4. 4, right? It's going to be, is it going to fit into 8? You know, is 8 going to fit into 4? No. So let's again have this drawn out. 2 squared, 2 to the 1, and then 2 to the 0. So this is going to be a 0, right? 2 to the 1, 2 to the 2, it does fit into 4. So that's a 1. Because we used it, it drew an even. So now there's nothing left. So then everything else is a 0. But notice that this takes up 3 characters, and this only needed, and these numbers needed basically 2 characters. So it's almost like a way to think of it is all the numbers in the decimal system, like 1 through 9, just require 1 place. Then when you get up to 10 to 100, it requires 2 places. Then you get up to the hundreds, and it requires 3, then thousands, 4, and just how it works is once you get to the next power and start needing the next power, then you need another space. Let's do 5. 5. Does 5 go into? Does 8 go into 5? No. Does 4 go into 5? Yes. So we're gonna make that a 1. We're gonna make this a 0. But because we use 4, then what's left? 1. So does 2 go into 1? No. Does 1 go into 1? Yes. So then, that's 5. 0, 1, 0, 1 is 5. So let's try 6. Does 2 to the 3rd, does 8 go into 6? No. So that's a 0. Does 2 to the 2, which is 4, go into 6? Yeah. So it's going to be a 1. So then you subtract off 4. So then 2 is left. So then you get 2 to the 1 is 2. So then you have 2 minus 2. And then it's even. Then that's it. Minus 2 then you're even, and then the next one would be 0 because there's nothing left. Um, let's say, yes, this is 4, this is 5, this is 6. Um, so let's try to clear up some space here. Hmm. Nah, I can't do that. Um, yeah, I can't clear up some space. Um, so let's go into 7. Does 8 go into 7? No. So it's going to be a 0. Does 8 go into does 2 to the 2, which is 4, go into 7? Yeah. So then you have 3 left. 3 left. 2 to the 1 is 2. So then 3 minus 2 is 1. And then 1 is left. So that's 7. Let's try 8. So this is the first time where 2 to the 3rd, right, is 8. 8 does go into 8, so it's going to be a 1. And then the rest is just 0, 0, 0. Then 9, it's going to be 1, 0. And you almost kind of can do it in your head now because you just know it's going to be the same thing plus 1, right? And then 1 is in this place. 10, it's basically just going to be, yeah, 1, 0, 1, 0. That's it. So that's how you count.